Welcome to part 2 of 8.9. The arc length function. Sometimes it's going to be helpful and useful to have a function that measures the arc length of a curve from a particular starting point to any point on the curve. If a smooth curve C has the equation y equals f of x and you have a is less than or equal to x is less than or equal to b, let the function s of x, usually lowercase s like this, represents arc length, be the distance along function C or curve C from the initial point P sub 0 a comma f of a to the point Q at x comma f of x, then S is the arc length function. So this x, again, is somewhere between a and b. So our function S of x is now going to be equal to the integral from a to any point x of the square root of 1 plus f prime of t squared dt. So what I did here is, because I'm creating an integral that's going to create a function written in terms of x, your integral has to be written, usually we use the variable t, we integrate it with respect to t, then when we evaluate it with x, then x goes into my function, and again a here will be an actual number. And that's how we create our function s of x. So in this problem here, it's stating, all right, we need a starting point. So let's look at example 3. Let's say your arc length is going to start at 1, 1 as your starting point. And this is my function. If I go anywhere to the right on that curve, so A is 1, B is something way out there, way out there, I can let x be my upper bound, create a function in terms of x, and then all I have to do is know what x value I'm going to end at, and I can find the arc length. So I can use this over and over again if they give me different endpoints. So using my s of x function, we'll integrate our arc length formula. So what we're going to do is we're going to take f of x here, the x squared minus 1/8 natural log of x, and we are going to find its derivative. Now remember, this is f of x, this is f of t. Don't worry, we'll switch it out in a second. Take the derivative of this, so the derivative of x squared is 2x. The derivative of the natural log of x is 1 over x. So let's go ahead and square it and do our plus 1. So again, I see x to the first on the top, x to the first on the bottom, and I'm going to square this. Good things are about to happen. If you FOIL this out, it's 4x squared minus the two terms, 2x and 1 over 8x multiplied together. Keep the minus sign from the middle. And then 1 over 8x times 1 over 8x is 1 over 64x squared. Again, the 2 and this 2 is 4, and 4 goes into 8 twice. This x and this x cancel, again leaving me with a minus 1/2. Then I'm going to add to the 1, which makes it a plus 1/2 in the middle. And wait a minute, the only term that changed was the middle from a minus to a plus. It has to factor to this binomial squared, but with the plus sign. And you'll see a number of homework problems will do this. We take this binomial squared, we put it in our square root. Square root cancels the power of 2. Now we're going to go ahead and integrate it from 1 out to x. Notice now, once I substituted in, I put t's here. I took out my x's and put in t's because we want to integrate it with respect to t. So if I integrate 2t, that's t squared over 2, which cancels this 2. 1/8 t to the negative 1, or 1/8 times 1 over t. 1 over t integrates to the natural log of t. We'll put in your x's, then minus, you put in your 1's. Now we want to simplify. Oh, right away, natural log of 1, I know that's a 0. So 1/8 times 0 is a 0. So minus 1 squared here. And so 1 squared is 1. This is my function here. So what does that mean? Does that mean I can pick any x on this curve. If I want to pick a 5, put 5 in here, simplify, combine any like terms, that's my exact value. If I want to go out to 10, put 10 in for the x's. If I want to go out to 50, put 50 in. As long as you're starting at the point 1, 1, I can go out to any x to the right of 1, 1 that I want, and it will tell me the length of the arc. And that wraps up our